Hi everybody. In time domain, the input-output relationship of a linear time invariant continuous system is represented by a constant coefficient differential equation. Constant coefficient differential equation. Okay, as shown here on the whiteboard. So in S domain, the relationship between input and output of a linear continuous time invariant system is represented by a transfer function, which is a rational function of S. It is in the Laplacian domain. So there are two expressions available. One is the constant coefficient differential equation, the other one is the transfer function, which is a rational function of S, y of s by x of s. So what we are planning to do is, we are trying to represent the representation, or we are trying to present the system, continuous time, linear time invariant system, in the form of a block diagram or in a form of a structure. So that is the objective behind this title. So for block diagram representation of a continuous time system in time domain, the differential equations are used. Some of the block diagram representations of this given direct relationship, which gives a direct relationship between time domain equation and S domain equation. So in that sequence, we are going to see how direct form 1 could be used for realizing a system in the form of a block diagram. So when we apply Laplace transform on the constant coefficient differential equation, you will identify that it will become S power n, omitting the input or the initial conditions, output initial state and the input initial condition, assuming that both of them are initially zeros, zero initial conditions. So when we apply Laplace transform, the Laplace transform of this equation number 1 will result in S power n y of s. I plan to take the remaining terms to the other side, so it will become minus a1 s power n minus 1 y of s minus a2 s power n minus 2 y of s minus a3 s power n minus 3 y of s, and so on. Finally it will become minus a n minus 1, correct, a n minus 1 s power 1 y of s minus a n s is not available, it is only y of s, because it will no longer be a differential term, it will be a n y of t. If it is transformed using Laplacian transform, it will become a n y of s. Similarly, the remaining terms, what are those remaining terms? The first term is b naught s power m, because d power m by dt power m of x of s is, x of t is available. So when we transform it, it will become s power m into x of s, assuming zero initial conditions, plus b1 s power m minus 1 x of s, and so on. The last term of this expression will become bm, yes, bm, look at this, bm x of s. So I have equation number 2 with me because of the usage of Laplacian transform on it. So I am trying to show you the expression here on the screen. Let us divide both the sides of this expression, equation number 2, right? I'll complete it. It will be x of s plus b1 bm x of s, correct? So divide by s of n on both the sides, s power n by on both the sides, this equation will become y of s minus a1 times, right, a1 times s power n minus 1 divided by s power n. So this will become simply s power 1. Am I correct? So I can write this as simply s power 1. Do you want me to write it again? Yes, it is s power n minus 1 divided by s power n, correct, dividing by s power n on both the sides. Y of s minus a2 s power n minus 2 divided by s power n, y of s, like this. The last term of this expression will become bm, isn't it? S power m, right, divided by, what is the factor? It is, you have to divide by s power n on both the sides. S power n on both the sides. And s power m and s power n, letting m is equal to n. So this will become s power m by s power m, or s power n by s power n, because m is equal to n in this case. X of s plus b1 x of s into s power m minus 1 or n minus 1 divided by s power n, right, plus etc. It goes up to bm minus 1 s1 x of s by s power n plus b1 or bm, correct, bm, the last term. It is x of s by s power n. Agreed? So the above equation can be directly represented in a block diagram, and the block diagram, after representing this equation in a form of a structure, is called in the name of direct form 1 structure. So realizing this equation in the form of a structure is called the direct form 1 structure. Direct form 1 structure. That structure will make use of integrators for the input and output signals, and it will be realized with memory. And direct form structure provides a direct relationship between time domain and s domain, because now the equation is completely in s domain. Agreed or not? You can even reduce this. I'll tell you. S power n minus 1 divided by s power n will become simply s power minus 1. So that can be written as 1 divided by s, or I can say it is 1 divided by s, like this. Correct? Whereas the next term will become simply s power n minus 2 divided by s power n. S power n will be cancelled, so it is s power minus 2. So it will become 1 divided by s squared. Agreed? 1 divided by s squared. Y of s by s squared. Y of s by s squared. Similarly, when m is equal to n, you can say that this will become simply, this will become s power n by s power n, so it will be cancelled. In the next case, you can find out s power m minus 1 divided by s power n, so it will become simply s power minus 1. What is remaining is s power minus 1, which is written as 1 by s, x of s by s, x of s by s. Or you can write in this case as, s power 1 divided by x power 1 divided by s power n. So this can be represented as s power n minus 1. Correct or not? So 1 by s is the important module or block required for realizing this. That is what shown here in the diagram. You can notice this is called, you can notice this. This, the previous one is the relationship. Y of s is the output. I'll tell you that this is output minus a1 times y of s by s. Look at the first term. It is y of s by s multiplied by minus a1. You can trace that y of s by s is available here, and it is multiplied by minus a1. So y of s is drawn and it is tapped out. Just look at this, and it is y of s by s. Now it is multiplied by minus a, and it will be added with y of s, so that y of s can be created. First loop is over. Next term, what is the next term present here? What is the next term present here? It is y of s by s squared multiplied by minus a2. So what you can do is pass on this y of s by s one more time through 1 by s module. So you will get y of s by s squared in this root, and it is multiplied by minus a2. So you will get minus a2 times of y of s by s squared. That will also get added with the previous term. Right? It is a accumulation of all those terms. The next, like this, when you go ahead, you can find out that this will become y of s by s power n multiplied by minus a power n s all these branches will get added to produce y of s finally. If this is okay, then we shall go to the next part of the expression. What is the next part of the expression? It is b naught multiplied by x of s. Look at it. What is b naught divided by b naught multiplied by x of s? You can notice that x of s is taken and it is multiplied by b naught. Yes, the first term is ready. The next term will be, in this case, will be, what is the next term? It is x of s by 1, x of s by s into b1. Yes, are you getting this? X of s by s. Yes, x of s by s. You can note down, since x of s is the input, the branches are present in the forward path itself. X of s by s, and you can multiply it by b1, and b1 multiplied by x of s by s will get added with the previous term. Like this, the next term will be, what is the next term? It is s power n minus 1, x of s divided by s power n minus 1. So what you can do is, you can find out like this. If you pass on consecutively through 1 by s, 1 by s, 1 by s, at one fine instant you can find out x of s passes through 1 by s power n minus 1. So obviously x of s divided by 1 by s power n minus 1 multiplied by bn minus 1 will also get added with the terms what we have produced so far. Not only this, right, there is one more. You can notice the last term is s of s, x of s divided by s power n. So this x of s by s power n minus 1 is also furthermore passed through the block diagram. You can notice that it is x of s by s power n. So it is multiplied by bn. So bn multiplied by x of s by s power n will also getting added. So this is how the Laplacian domain representation of a continuous time differential equation in the form of s variable, 1 by s, 1 by s, 1 by s. So 1 by s is the important module. Multiplier is another important module. Also adders are also present in this chain. So to produce an output from x of s to, so this is called direct form 1. I'll write it here. Direct form 1 structure of a CT LTI system in terms of its differential equation converted into Laplacian domain. So ultimately you are writing y of s is equal to, y of s is equal to minus, what is it? It is minus a naught into, or I'll put it in this way, a1 into y of s by s, minus a2 times y of s by s squared, minus a3 times y of s by s power 3, etc. It goes on and on. The last term of this y of s will become simply minus a n y of s by s power n. Similarly, as far as the x of s terms are concerned, the first term will be b naught into x of s, right? The next term will be b1 into x of s by s. Like this, you will go up to, say for example, the last component of this x of s branch will be bn nth order system. So x of s by s power n, right? X of s goes via this chain of 1 by s molecules, whereas y of s is passed via this 1 by s modules like this. So at every time it is multiplied by a scaling factor and they are all added again to generate this output. Similarly, this side also, all the terms are multiplied by the appropriate multipliers based on the coefficients of them, and they are all added to produce the final output y of s. So x of s is applied as an input and y of s is produced as an output of this direct form 1 structure, right? All right, I'll go to direct form 2 structure. Here also the differential equation governing CT LTI system is given in the form of an equation like this. More clearly it is stated, and it is a snapshot taken from a textbook, and you can find out upon applying Laplace transform, taking Laplace transform on the above equation, you will find out with assuming that 0 initial conditions, you will get s power n y of s, correct? S power n y of s, the first term will become s power y of s plus a1 times s power n minus 1 into y of s plus a2 times s power n minus 2 into y of s right, plus etc. You can notice the last but one term will become a n minus 1 s power 1, isn't it? Yes, because it is d by dt of y of t, isn't it? If Laplace transform is applied on it with 0 initial conditions, you can notice that it will become s into y of s, and the last term will be a n y of s. Similarly, on the other side, you will get b naught s power m x of s plus b1 s power m minus 1 x of s plus b2 s power m minus 2 x of s. Like this it goes up to say b m minus 1 s power 1 x of s and b simply bm x of s alone. So this is the equation, the same differential equation, but it is represented in the Laplacian domain. Equation number 1 and 2. These two were taken for direct form 1 also. Simply the representation of CT LTI system in the form of a block diagram in time domain representation is using constant coefficient differential equation is called a block diagram. Whereas if it is transformed into Laplacian domain or some other frequency domain, here Laplacian frequency is a complex frequency, Laplacian domain, S in the equation in the form of S, and then if you start realizing it in a block diagram, it is called as, what is it? It is called in the name of structures, right? I'll just move on further. When we divide the equation throughout by s power n and assuming that divide by s power n and assume let m is equal to n in your equation, you will notice that this will become y of s c plus all those terms are kept on the place at which they are all actually available, y of s by s plus a2 y of s by s squared will appear. Then and there, if you want, you can just verify with the previous equation. Take the second equation, divide by s power n on both the sides throughout, and assuming m is equal to n, you can notice that s power n minus 1 divided by s power n will become simply s 1 by s. Yes, that is what we have put. And if you start moving further, you will find out at one fine instant it will be a n minus 1 y of s by s power n minus 1 plus a n, right, y of s by s n. Agreed? And you can notice on the right hand side you will have b naught into x of s is the first term. But why? Because you can notice that the s power m divided by s power n will become simply m and n are equal. We have assumed it. M and n are equal. We have assumed it. So it will become s power n divided by s power n. So this will become simply b naught x of s. Right? B naught x of s. And if you move on further, you will find out that for instance b1 is equal to s power n m minus 1 x of s plus b2 s power m minus 2 into x of s. Correct? You can proceed up to m terms here. Of course, m is equal to n. I could understand what you are trying to tell me. S into x of s. The last term will be simply bm x of s. When n is equal to m, you can very well replace m by n. There is no need for it. Right? Dividing throughout this. Have I done it properly? Have I done it properly? I just want to know about it. No. Because if this term is divided by s power n will get cancelled. Here if you divide it by s power n, you can find out s power m is equal to s power n. So it will become 1 by s squared, 1 by s power n minus 1, 1 by s power m should all appear. So in this case, you can notice the sequence are not properly written. I can simply remove all those terms and I will proceed with. I will show you. The first term will s power m divided by, right, it is actually b naught into s power m divided by s power n. It will get cancelled. So it is simply x of s alone. Whereas the second term will become s power, what is already available, it is s power m minus 1, isn't it? It is s power m minus 1 divided by s power n. M and n are equal. So you can notice that it will become simply, what is it? It will become simply s x of s by s. The next term will become s power m minus 2 divided by s power n. So this will become simply x of s divided by s squared. Similarly, the last term bm minus 1, last but one term will become s power m minus 1. Similarly, the last term b of m x of s divided by s power m is the equation. Is this okay? If this is all right, I think we can proceed further, because y of s can be taken as a common factor from the left hand side expression. So this will become 1 plus a1. Y of s is taken already outside, so this will become 1 by s, right, plus a2 into 1 by s squared, agreed, plus etc. You can notice the last term will become 1 divided, it is only a n minus 1, right, into 1 by s power n minus 1 plus a n into 1 by s power n, yes, which is equal to b naught into, or let me take x of s outside as a common factor. So we can notice that x of s is taken outside, so this will become b naught plus b1, right, 1 by s plus b2 1 by s squared, etc. The last but one term will become bm minus 1, 1 divided by s power m minus 1. The last term of this expression is bm into 1 by s power m. You can notice how the equation is rewritten. Since m is equal to n, you can very well replace m and n, because they are interchangeably used here. What is really finally obtained? So you can notice that it will become y of s by x of s. Agreed? Y of s by x of s. It is equal to, what is it? b naught plus b1 1 by s plus b2 1 by s squared plus etc. Right? Etc. The last term is bn 1 by s power n. The whole divided by, the first term is of course 1. The next term will become 1 a1 1 by s plus a2 1 by s squared plus etc. If the terms are all rearranged, you can find out at one point, instead it will become an 1 by s power n, because m is equal to n. You have to keep that in your mind. Let, I am going to just make another substitution here. You are available, or you are given with y of s by x of s. Now we have to divide, or we have to rewrite this expression by introducing a new term. That new term could be w of s. Just imagine, multiply and divide by w of s will cancel out the presence of w of s at any time. So you can revert to the original expression y of s by x of s, correct? So you will get w of s by x of s is equal to y of s by w of s. It does not change any format or the difference in equation, where I just imagine the denominator term of the previous expression. Just make comparison between this equation. The equation is 3 and this equation is identified as 4. Upon comparison between 3 and 4, you will definitely find out that w of s by x of s is equal to, it is considered to be 1 divided by 1 plus a1 1 by s plus a2 into 1 over s squared plus a3 into 1 over s cube plus etc. a n minus 1 1 divided by s power n minus 1. Similarly, a n multiplied by 1 over s power n. Right? Then what is y of s by w of s? Right? You must have a justification for that also. When you imagine the denominator is equal to the first part, obviously the numerator will be considered to be y of s by w of s. So y of s by w of s is equal to b naught. Yes, b naught is the first term, plus b1 1 over s plus b2 1 over s squared plus etc. The last term is bn minus 1 1 over s power n minus 1 plus bn 1 over s power n. So these two, equation number 5 and 6 will be realized separately, and you can find out when you realize it like that. See, x of s is the input. I just imagine the diagram looks like this. W of s is the output as far as the fifth equation is considered. So you will have a realization structure in between. Similarly, W of s is the input, and Y of s is the output. You can just imagine. There will be a block diagram for this. Y of s is the output. So these two equations, what are they? Equation number 5 and equation number 6 could be realized separately in block diagram 1 and 2, and when you merge you will find out that it is very easy for you to realize it with less number of components as when compared to direct form 1 structure. You can notice that this is direct form 2 structure where x of s is the input and y of s is considered to be the output. X of s is the input and w of s is the output. That's what I say. X of s is the input and w of s is the output. You can realize this part alone separately, right? This part alone separately, this is realized. So this is obtained from w of s by x of s, isn't it? X of s is the input and w of s is the output. That part is alone represented 1 divided by something, right? Please look at it. 1 divided by 1 plus a1 by s plus a2 by 1 by s squared plus an into 1 by s power n. Like that, you see, this is what shown here. W of s by s of s. I'll write it here. If you want, I'm ready to write w of s by x of s is the first equation. It is 1 over 1 plus a1 times 1 by s plus 1 over a2 times s1 by s squared, etc. Correct? When we cross multiply this, you will find out w of s is equal to, or w of s multiplied by, yes, numerate, when you multiply like this, cross multiplication, when you multiply like this, w of s multiplied by 1 plus a1 into 1 by s plus a2 into 1 by s squared, etc. Isn't it? Which is equal to x of s. That is how the equation will be rewritten. When you expand this equation, this will become w of s plus a1 into w of s by s plus a2 into w of s by s squared plus a3 into w of s by s cube, which is equal to simply x of s. So if you rearrange this equation, this will become w of s is equal to, what is that? It is right. W of s is equal to, when you keep w of s alone on one side, when you take the remaining terms to the other side, it will become x of s minus, or I will put it in this way, x of s can be treated as the last component. We shall take minus a1 w of s by s minus a2 w of s by s squared minus a3 times w of s by s cube, right? Like this you will get the terms. So w of s by s multiplied by minus a1 multiplied by minus a1, w of s by s square multiplied by minus a2, w of s by s power n minus 1 multiplied by a power n minus, a n minus 1, w of s by s power n multiplied by minus a n. When you add all these parts, you will find out that the last term along with x of s will simply result in w of s, right? So you can notice w of s is the output, whereas the output is generated by simply taking minus a1 times of w of s by s, correct? a2 times of w of s by s squared, etc. This is how this equation is realized. Similarly, on the other side, if you find out y of s by w of s, y of s is the output and w of s is treated to be the input. Y of s is the output and w of s is the input in this case, as far as the second block diagram is concerned, right? So you can find out here also, when we rearrange the expression, this will become, what? How will you rearrange? The rearranged expression will become y, which is equal to, what is the expression given to you? It is b naught into 1 by s, isn't it? You can tell me what is available here, right? Want me to show you the previous slide? Yes. You can notice when you cross multiply these two equations, sixth equation, you will find out b naught into w of s. Yes. You can notice that this will become simply y of s is equal to b naught into w of s plus b1 into w of s by s plus b2 into w of s by s squared plus b3 into w of s by s cube, etc. Correct? That is how every time the w of s is passed through 1 by s, 1 by s, 1 by s modules, and they are simply multiplied by bn, bn minus 1, b1, b2, b naught, all those coefficients, and they are added to produce y of s, they are added with w of s on one side, w of s multiplied by b naught of s, the first term, right? If this is not clear at this stage, don't worry at all. I am going to show you how to realize using a simple block diagram. I hope thereafter you can easily understand. With a numerical problem, I think I can introduce, just I'll give you a problem, numerical problem, where the block diagram, how is it really realized and all, you can easily understand it. I'll give you the statement of the problem first. Draw the direct form 1 and direct form 2 structures, or even direct form 1 structure first and then we will go to direct form 2 structure, one by one. Direct form 1 structure, I will give you that. Yes, direct form 1 structure of the continuous time system, LTI system given below. Say for example, the equation goes like this: d squared y of t divided by dt squared plus 5 times of dy of t divided by dt plus 4 times of y of t, which is equal to dx of t divided by dt. It is a constant coefficient differential equation. So when you want to realize this using direct form 1, what should you do? The solution part. I'll take the given equation and apply Laplace transform on both the sides. When I apply Laplace transform, this will become s squared y of s plus 5 times of s into y of s, assuming 0 initial conditions. 4 into y of s, y of t, if it undergoes Laplace transform, it will result in y of s, right? It is y of s, which is equal to s into x of s, assuming 0 initial conditions. And if you divide by s squared on both the sides, it will become y of s plus 5 times of s into y of s by s squared plus 4 times of y of s by s squared, which is equal to x of s by s into x of s is already available. I am going to divide it by s squared. So this will become s squared by s squared. So this is y of s plus y of s by s plus 4 times of y of s by s squared is equal to x of s by s. Agreed? So what you will do finally, you have to rearrange the expression such that output y of s is alone available on one side, remaining all other terms are taken to the other side. So this will become minus 5 times of y of s by s minus 4 times of y of s by s squared plus x of s by s, right? Just keep this equation in your memory. Let us try to realize this using a block diagram. What is that equation? This will be y of s is equal to, I'll rewrite it for the purpose of realizing it in a structure, y of s by s minus 4 times of y of s by s squared plus x of s by s, right? So you can just take x of s is at this position and you can imagine that y of s is at this position. So x of s is to be passed through 1 by s module once. I'll put it like this. It will become x of s by s. Yes, and it need not be multiplied by any other component. So you can simply take this term outside and it will be passed to a module. So this will be passed to the next level, where the remaining terms are all simply y of s terms. So our y of s is tapped outside as a feedback and passed through 1 by s. So you will get y of s by s at this point. So this will become y of s by s. And if you multiply it by a term, what is the term? This must be a multiplier with the multiplication coefficient is minus 5. So you will get minus 5 y of s by s squared. Sorry, s at this point. So you will have to add this product by another term, because there is one more term which requires you to pass it through one more 1 by s, so that you will get y of s by s squared at this point. And it will be multiplied by a multiplier with a multiplication coefficient minus 4. If you add all of them, you will get like this. So this branch, two terms are to be added with this term also. So I just take an adder here. So you can pass this on one side and the other branch is also available here, where the two other terms are present here, and they'll all be put together to produce y of s. So this is called direct form 1 structure realization of continuous time differential equation. It's a structure like circuit diagram in ordinary cases, right? I'll state another problem also to realize it in the form of direct form 2 structure. Let us go for how to realize it continuous time system, LTA system, in the form of direct form 2 structure. A new problem, d squared y of t divided by dt squared is a constant coefficient differential equation. 0.6 times dy of t divided by dt, yes, plus 0.7 times y of t is equal to d squared x of t divided by dt squared plus 0.5 times of dx of t divided by dt plus 0.4 times of x of t. Now the system is to be realized using direct form 2 architecture. The solution, I'll try to solve it, right? Upon application of Laplace transform taking Laplace transform on both the sides of the above equation will result in s squared, assuming 0 initial conditions, s squared y of s plus 0.6 times of s into y of s plus 0.7 times of y of s is equal to s squared x of s plus 0.5 times of s into x of s plus 0.4 times of x of s. Just see the terms, how the Laplace transforms are, the Laplace transform versions of those terms are written here. All those things are presented here for your purpose. Once you understand this, then divide the equation throughout by s squared. If you divide, you will find out that the first term will contain y of s alone, whereas the second term will have 0.6 y of s by s, yes. The next term will become simply 0.7 y of s by s, yes, s squared, isn't it, right? This is on left hand side, whereas at the right hand side you will find out x of s by s squared will get cancelled, whereas the second term will become 0.5 x of s by s, because already s was there, s divided by s squared will become 1 by s. The next term will become 0.4 times of x of s by s squared, because throughout the equation we divide by s squared. See, I just want to take this expression to the next slide, where you will find out that this will become y of s. If you take y of s as a common factor, it will become 0.6, 1 plus 0.6, 1 by s plus s, 0.7 into 1 by s squared is equal to x of s multiplied by 1 plus 0.5 times of 1 by s plus 0.4 times of 1 by s squared. So you can write this as y of s by x of s. You have to rearrange it in the form of transfer function. So what is the numerator? So it will be 1 plus 0.5 times of 1 by s plus 0.4 times of 1 by s squared divided by the denominator will be 1 plus 0.6 by s plus 0.7 by s squared, right? Let us introduce a new term so that this y of s by x of s can be written as w of s. I'll write it like this. I introduce a new term w of s by x of s, and w of s is, since introduced the numerator, it is to be equivalently put up in the denominator also at any moment, so it will turn back to y of s by x of s model. So I'll take the denominator alone as w of s by x of s. The numerator is alone represented by the y of s by w of s. So this term I can find out that w of s by x of s is equal to, what is w of s by x of s? It is 1 divided by 1 plus 0.6 times of 1 by s plus 0.7 times of 1 by s squared. Yes, are you getting this? Whereas the second term will be y of s by w of s is equal to simply 1 plus 0.5 times of 1 by s plus 0.4 times of 1 by s squared. So you get two equations now. The second equation is not a big issue, whereas the first one has to be properly rearranged. It has to be properly cross multiplied to get the proper expression for w of s. So if you ask me to do that, I'll write it like w of s is equal to w of s plus 0.6 times of w of s by s plus 0.7 times of W of S by S squared is equal to X of S cross multiplied. And if you keep only W of S on one side, the remaining terms, if they are all taken to the other side, this will become 0.6 times of W of S by S minus 0.7 times of W of S by S squared plus X of S will appear, right? So this is the equation to be realized, assuming that W of S is an output term, right, whereas X of S is the input. You can notice that the X of S is directly obtained, whereas X of S is directly available in this equation without any term in the division or multiplication, whereas W of S is passed through two consecutive terms of 1 by S, right? Agreed or not? You can guess what is going on here, right? And each term is to be properly multiplied by 0.6, minus 0.6 and minus 0.7. Agreed? Right? They are all to be added together. Sorry. They are supposed to be added, right? So this is how this equation is to be realized. Then I'll go to the next one. I'll show you the remaining pending expression. What is available? This is W of S by X of Y of S by W of S is in pending. When I realize this, Y of S by W of S is equal to simply, what is it? It is Y of S by W of S is equal to 1 plus 0.5 times of 1 by S plus 0.4 times of 1 by S squared upon cross multiplication, assuming the denominator contains 1 here. So this will become simply Y of S is equal to W of S plus 0.5 times of W of S by S plus 0.4 times of W of S by S squared. So this expression can be written as Y of S is the output term, W of S is the input term, and you can notice that W of S is to be again passed through minimum two modules of 1 by S, so that you will get W of S by S in one part, and it is needed to be multiplied by 0.5. 0.5 is the multiplication factor, and W of S by 1 by S squared could be obtained at this point simply because consecutively it is passed through 1 by S modules two times, and it is to be multiplied by 0.4. If you add all those factors, you can find out that this produces Y of S along with the W of S, correct? This is also required. So in this way they are multiplied and added. So this is for this part. So the last one will become, last diagram will become simply, I'll keep W of S as a constant, W of S as a constant, and I'll pass it through successively. Consecutively it is passed through 1 by S modules, and on one side if they are multiplied by minus 0.6 and by minus 0.7, if I add the results along with X of S, this part denotes W of S is equal to minus 0.6 times of W of S by S minus 0.7 times of W of S by S squared plus X of S, right? This part is over. I have shown you that, right, before 2 slides. This part is over. I'll just move on to the next one. Now keeping W of S as the input on one side and tapping out W of S by S and multiplying it by 0.5, and W of S by S squared term is multiplied by 0.4, so that I'll get two other terms, and it is to be added with W of S to produce, yes, to produce Y of S in this part. You can notice that Y of S is produced here, right? Y of S is produced. So this is the direct form 2 structure of the constant differential equation given to you.